All right, today we are going to untangle one single, incredibly powerful idea. It's an idea that, surprisingly, connects the basic laws of physics to the very nature of life and even to how ideas spread through our culture. It's a deep dive into information itself.
So, let's start with a puzzle. What on earth could possibly link these three things together? A random coin flip, a super complex living cell, and an idea that just goes viral. I know, it sounds like a riddle, but stick with me, because by the end of this, you'll see the amazing thread that ties them all together.
Okay, let's get into it. To solve this mystery of ours, we first need to get a handle on a concept you actually already know, you just might not have a name for it. It's that feeling you get when you guess something right against the odds.
We're going to call this feeling surprisal. So imagine you call heads on a coin toss. If you get it right, you feel a little jolt of surprisal. But now, what if you correctly guessed the outcome of 8 coin tosses in a row? The surprisal you'd feel would be massive, right? That's because it's so incredibly unlikely. Surprisal is really just a way to put a number on the amount of information you get from making a correct prediction. But the real power tool here is something called net surprisal. This isn't just about one guess. It's about the difference in information between two different states. You can think of it as a measure of how far something is from just being, well, average and boring. It's a way to quantify potential, to measure how much a system stands out from its environment.
The physicist Myron Tribus put this so well. He said that these concepts, they're not really properties of the coin itself, they're numerical encodings of states of knowledge. It's a huge mental shift. It's not just about the world out there. It's about what we know about the world.
And don't think for a second this is just a philosophical idea. No, net surprisal links directly to real-world energy. It's a concept with teeth, powerful enough to solve some really old and tricky puzzles in thermodynamics. You know, the science of heat and energy.
Okay, check this one out. Imagine you have a box, no plugs, no batteries. You pour boiling water into the top and solid ice comes out the bottom. Now, for that to be physically possible, how cold would the room around the box have to be? Your first thought might be, well, freezing, of course. But the real answer is way cooler.
The answer is, the room just has to be under about 100 degrees Fahrenheit or 37 Celsius. How is that possible? Well, it's because that boiling water is in a state of absolutely massive net surprisal. All that surprisal is a measure of highly concentrated usable energy. There's such a huge energy gap between the hot water and the just warm room that it can actually power a cycle to freeze the water, dumping the extra heat out into the room. It's wild.
So let's see how this builds. We're going from physics to the very definition of life itself. I mean, if net surprisal measures how much something departs from its surroundings, what could possibly be more different from its surroundings than a living creature?
Now, to make that jump, we need a special flavor of net surprisal. It's called mutual information. All this does is measure how correlated two things are. It's the information you get when you realize two things aren't just random. They're connected. They move together. And this is precisely what life does. A living thing is, at its core, an information engine. It sucks in free energy from the sun, from food, and it doesn't just waste it as heat. It uses that energy to build and maintain order, to create non-random correlation. You can think about this in two ways, kind of like a yin and a yang. First, you've got the inward-looking stuff, the correlations inside an organism. Think about how a protein enzyme folds into a perfect, specific shape to do its job, or how all your tissues work together. Then you have the outward-looking correlations. This is how the organism relates to the world, a cell membrane creating an inside versus an outside. A tree growing a trunk specifically to get its leaves up into the sunlight.
So here's the crucial point. If life is going to all this trouble to create these amazing, intricate correlations, all this precious information, it needs a way to save it. It has to pass it on. You can't just let it all disappear when the organism dies.
And over billions of years, evolution came up with two absolute genius systems for this. First, of course, is the genetic code. DNA is basically a digital hard drive for storing all the information needed to build an organism's correlations. But way more recently, a second system showed up, the mimetic code. These are ideas, memes, stored not in molecules but in our brains, passed between us through language and art and culture.
Now, these two replicator families, they play by different rules. Genes use molecules and copy themselves through biological reproduction over a timescale of billions of years. Memes, on the other hand, use our brains and our media, and they copy themselves through communication on a timescale of just thousands of years. They're both in the business of copying information, just using totally different hardware.
And this is where it gets really interesting and maybe a little dramatic. According to this way of thinking, these two systems are not always on the same team. There's an unconscious struggle for hegemony, basically a power struggle between them. Our genes want one thing, survive and make more copies. But our ideas, our memes, they might want something totally different.
You can think of it as a battle between the ancient sword of our genetics and the much newer, much faster pen of our ideas. And in that fight, we, the living organisms, are the vehicles. We're the resources. We are the spoils of war, caught between the competing interests of our genes and the ideas that have taken up residence in our mind.
Okay, let's step back and pull all of this together. What have we actually gained by looking at the world through this new lens of surprisal and information? What does it let us see that we couldn't see before?
We basically went on a huge journey. We started with a simple physics idea, net surprisal. We saw how that scales up to define life itself as an information engine, a machine that literally builds order. Then, we found out that this order, this information, gets stored and copied by two powerful and sometimes competing systems, our ancient genes and our fast-moving memes. It's one single, continuous thread connecting the laws of energy to the struggle for survival, not just in our bodies, but in our culture too.
This brings us all the way back to that old phrase Myron Tribbius quoted, "Knowledge is power." Through the lens of net surprisal, that's not just a nice metaphor. It's physically true. Knowledge, information, is directly connected to power, to available energy, to the ability to create order where there was chaos.
So I'm going to leave you with this final question to think about. If ideas are basically replicators, just like our genes, and they're competing for survival by using our minds as hosts, when you hold a really powerful belief, whose interests does that belief really serve? Your interests, your genes' interests, or the interests of the idea itself? It's a surprising question that comes from a very surprising connection. Thanks for joining me.